All right, so now let's introduce a very important equation in economics, which is the equation of exchange, or also known as the Cambridge equation. And all it says is m times v equals y times p. So what it says is that m is the nominal money supply. You can think of it as the coins in circulation. V is the velocity of money, and that can be thought of as the number or the frequency at which money changes hands. I'll say something about that in a second. And Y is real production, so that's the output of apples, the real things that we have, apples or cookies. And P is then the price level. So let's say something about velocity. So first of all, velocity can be assumed to be constant, at least in the short run. And the way you may want to think about it is like this. Let's say at the end of the month, you get your paycheck for the next month. And if you withdraw all the money from your paycheck in order to, at the beginning of the month, and you keep the entire money of your paycheck, let's say your paycheck is $100 and you keep $100 now in your wallet and you spend the entire $100 over an entire month. That means that the velocity is actually very slow because the money that is in circulation changes hand very slowly. But let's say suddenly we introduce ATMs and you can withdraw money at every corner of the street. So now let's say instead of withdrawing the money from the bank at once for the entire month, in which case the money would now change hands once over the month, let's say if every week you withdraw $25. So now everyone keeps much less money in their wallet, but that money must go through the economy at a much higher rate. So the velocity would go up. So that is how you can think about it. But we don't need to spend much more time on it because at least in the short run we know that velocity is a constant. So we denote that by a vertical bar. So at least in the short run, velocity is constant because velocity only changes as a result of such things like, for example, the introduction of the ATM. So the automatic teller machine has increased the money that people hold and their velocity. Okay, so now we are interested in the price level. Well, we can rearrange this equation and say, if the money times its velocity must be equal to the output of real goods and services times the price level, then I can rearrange this equation to identify the price level simply as m times v, which is a constant, over y. And now let's keep it simple. Let's just assume velocity is 1. So then we can say the price level is equal to the money supply over the real output of goods and services. Okay, so let's just consider an example. Let's say I have an economy, and in this economy I have coins. So let's say I have a coin, make it a little bit smaller, and then I have another coin, and maybe another coin. So this is the money supply. Those 3 coins is M. And let's say we produce real goods and services. And let's say we only produce cookies. So let's say I have a cookie here. And let's say I have 2 more cookies. Okay. So now the cookies, that is the real output of goods and services. That's the Y. Okay, so now we exchange goods. So let's say there is somebody who has a coin, wants a cookie, buys that cookie. Well, this person, buys that cookie, and there's another one who buys that cookie. And then maybe there's again another period. So now maybe there's this one who received the cookie, the dollar also wants a cookie, but buys it from here. and maybe that one buys it from there, and this one buys it again from here. So in this case, if we assume that the velocity is constant, we would say, okay, the money supply is 3, we have 3 coins, and we have 3 cookies, so the price level is 1. Okay, so now let's create inflation by having more money in circulation. Okay, so now let's say if I have 6 coins in circulation, but still I have only 3 cookies. So let's say there is a cookie store, and a customer comes in with 1 coin and says, I would like to have that cookie. But now maybe another customer also happened to be in that store, and that customer has already 2 coins. So now that other customer that has already 2 coins sees, there is about a transaction to happen where somebody's buying the cookie for 1 coin. So now the other customer with more money in its wallet will say, you know what, I will give you 2 coins for the cookie. So he may outbid the one who had offered only 1, and what happens is that now the price for a cookie, it's also by some kind of the invisible hand of the market, will go up to 2 coins. And again, so now the only thing that has changed is that we have our equation m, there it is again. So now the only thing that has changed is that we still have 3 cookies, but our money supply has increased to 6. So now the price level is 2, or the price level moved from, or changed from 1 to 2, which is equal to 100% inflation. So this is a very powerful equation that is, pretty useful in explaining and understanding inflation. It shows that whenever the money supply grows faster than the output of real goods and services, there will be inflation. And likewise, when the money supply cannot keep up with the output of real goods and services, then the price level will come down. This is what happened during the 1920s under the gold standard. So in the 1920s, many of you remember that from, let's say, your history lesson. They were known as the Roaring 1920s. Well, they were roaring because they produced a lot of output. But the money was tied to gold. If a bank wanted to introduce a gold dollar, it needed to be backed by gold. But because gold could not be discovered at the rate as fast as the output, what happened is that the output grew faster than the money supply, and according to our simple formula, what happened in the 1920s is that the denominator grew much faster than the numerator, and the result was deflation. Okay, so we can actually take a look quickly at an example of how to work with the Cambridge equation. So we assume velocity is 1, so we start out again, m times v equals y times p, and then we can say, okay, p equals m times v over y. So now in year 1, if the money supply is 100, the denominator becomes 100 times 1, and if we produce 100 apples, then the price level is 1. Okay, so now what happens in year 1? Velocity is still constant, but the apple production went up to 125, but the central bank could only get 10 additional gold nuggets in this case. So the money supply increased to only 110. So let's apply the formula. So in this case, we have the price level equals M 110 times 1 over the new output 125. So that is 110 over 125, and I think this is 0.88. Let me double check, but it should be 0.88. So if I do 110, where's my calculator? 110 divided by 125, that is 1.88. Then that would mean, in this case, we had 12% deflation. Okay, so the new price level is 0.88 or 12% deflation. Okay, I'll just stop here, and then in the next video let's talk a little bit more about that equation of exchange and why money is always a monetary phenomenon.